Hello class, welcome to this video on the Probability and Statistics Chapter 1 Test Review. So we're going to go over one of the versions of the test, so I do hope that you find this useful. So looking at the first question, at the beginning of the school year, a high school teacher asked every student in her class to fill out a survey to ask for their age, sex, the number of years they have lived at their current address, their favorite school subject, and whether they plan to go to college after high school. Which of the following best describes the types of variables that are being measured? So let's take a look. So we have their age, their sex, the number of years, so this right here is is age, which is quantitative, so it's something measurable, right? The sex is is a label, so this is categorical, right? Number of years, that's quantitative. I'll just use Q for that. And then let's see, their favorite school subject, that's categorical. Whether they plan to go to college, whether they plan to go to college after high school, that's another categorical. So here we see there are 3 categoricals and 2 quantitatives. So the answer is D. All right, so now number 2, it says questions 2 to 4 regard the following scenario. In MLB, the Young Award is given each year to the best pitchers in each of the 2 leagues, the American League and the National League. The histogram below shows the distribution of the earned run average for the past 50 recipients of the Young Award in the National League. Okay, so we got the histogram here. What's the overall shape of the distribution? So the shape of the distribution looks like this, right? So that looks to be skewed left. The longer tail is on the left side, right? So it's skewed in that direction. So this one's skewed left, so that's B. The mean of this distribution, the mean of this distribution, because remember the median is the halfway point, where it's 50% to the left, 50% to the right. So in this case, if we were to calculate the mean, if there's 50 recipients, then that means once we reach the 25 mark, then that's about the halfway mark, right? So this is 2, this is 4, or this is 6 over here, and then this is 11. So right now this is 8. This is 19. So this is approximately where the median is. That's approximately where the 50% mark is. And so because the tail is skewed, or because the longer tail is on the left side, the mean is going to be pulled in that direction. And so the mean might be somewhere around there. It's going to be less than the median, all right? So if it's skewed left, it's going to be less than the median. If it's skewed right, it's going to be to the greater than the median. All right. Number 4, based on the shape of this distribution, what numerical measures would best describe it? Okay, so based on the shape of the distribution, since it's skewed, right, it's skewed left in this case, that means that we want to use, so if it were symmetric, we would want to use the mean and the standard deviation, right, for the center and then the variability. But if it's skewed right or skewed left, we would have to use the median, and we would have to use the IQR. Okay, so the IQR. All right. So based on the shape of this distribution, what numerical measures best describe it? We would have to use the median and the IQR because it is skewed. Otherwise, if it's symmetric, we would use mean and standard deviations. All right. The pie chart describes the distribution of favorite school subjects for 300 high school students. How many students reported that math is their favorite subject? All right, so we just have to see how many students, right? So first we got to figure out the percentage of math. In a pie chart, the percentages add up to 100, so we add these up, right, to see what we get. So we got 11 plus 8 plus 15 plus 8 plus 32 plus x equals 100, right? All right, so we got 40, 55, then you got 63, and then you got 63 plus 11, 74. So we got 74 plus x equals 100. So it's got to be 26% for math, right? 26 plus 74. All right, now it's 26%, so don't choose A, right? Because we want to do the how many students. So it's 26% of 300 students. So you got to do 0.26 times 300. So if you do that, it's just basically going to be 26 3 times, which is going to be so 26 times 3. So it's going to be 78. So it's 78 students. So the answer here is D. All right, so far so good. So the bar graph shows the state of birth of the first 8 United States presidents. What percentage of the first 8 US presidents were not born in Virginia? So this is not born in Virginia, right? So that means we're counting these ones. This is 2 presidents, the first 2. This one's 1, and then this was 1. So we got a total of 4, right? That's 4 out of 8. So 4 out of 8 times 100, that's 50%, right? So here, the answer is D. All right, which of the following choices gives 2 measures that are both resistant to outliers? All right, so 2 measures that are resistant. So resistance to outliers. Based on what we did before, okay, so if you look at the mean and the standard deviation, the mean is not resistant to outliers. The standard deviation is not resistant to outliers, so this cannot be the answer. The median is resistant to outliers, but the standard deviation is not. The IQR is resistant to outliers. The range is not, so it cannot be these. It has to be C, right? So the answer is C, the median and the IQR. They're resistant to outliers. So if I introduce an extreme value, it's not going to really impact them that much. All right, number 8. And you do want to explain this, right? So when you take the notes, it's not, when you do this, your corrections, or like when you watch this video and take your notes, you want to actually explain why that's the case. So in this case, the median measures the middle, right? The middle of the distribution. Right here, let's say that's the middle. Well, then if I introduce an outlier here, it's not really going to change where the middle of the distribution is, right? Let's say that's the middle. But then, and same thing for the IQR. If the IQR measures the range of the first 50% of the data, or the middle 50%, then if I introduce an outlier on the left side or on the right side, it's not really going to impact the IQR very much, right? Because the IQR measures the 50%, the middle 50%. All right, so without doing any calculations, which of the following distributions has the largest standard deviation? All right, so remember, the standard deviation is a measure of spread. So which of these is more spread out? In other words, which of these is not as flat, right? And more clumpy and spread out from everything. So this one has a little bit of clump here, right? With some spread here and here. So that looks pretty spread out. So it looks, spread out. Now this one's less spread out because it's more clumpy, right? And less spread makes it clumpy and makes it have a smaller standard deviation, okay? If it's flatter, then it has, or spread out, then it has a larger standard deviation. Okay, so now, and it's so for example, if we know that the average for all of these is right down the middle, right? For each and every single one, the average is in the middle because these are symmetric. And so if I look at the spread, okay, well, the standard deviation of this, or the spread of this part, is 0. We have small spread there, we have large spread there, right? Small spread, large spread. Now for these guys, we have large spread, large spread, large spread, large, equally large spread, equally large spread, equally large spread. Now this one, these don't have any spread from the middle. This has spread from the middle. This has large, a little bit, large. So it looks like the answer is B. It's completely separated. We see that there's large spread between these and these from the middle. It's spread from the middle, right? And therefore it's got to be B. All right. The 5-number summary for the weights in grams of 1,200 tomatoes grown in a certain greenhouse is given as 90, 113.5, 140, 161, and 236. About how many tomatoes weighed in at most 61 grams. So here we're looking at the 5-number summary. And remember that in a box plot, if you were to do a box plot, this is your minimum here, this is your first quartile, this is your second quartile, this is your third, and then this is your maximum. Now, so the way the box plots work is that that each of these represents 25%. So that's 25, 25, 25, and then 25 to make a total of 100%. Okay. So that means that if it says how many tomatoes weighed at most 161, at most means less than or equal to 161. So we're looking for, and then they said that 161 is the third quartile. So we want it to be equal to that, but we also want it to be less than that, right? So we want all of this. Well, then that means that it's going to represent 75% of the data, right? So we got 75%. So we got to do 75% of the total. Now the total is 1,200 tomatoes, right? So we got 75% times 1,200, and that's going to be our answer. Okay, so if you do that, we get 900 tomatoes. It's got to be C. All right, so let's look at number 10. In a class of 100 students, the grades on a statistics test are summarized in the following frequency table. What interval does the median grade fall within? Now the median is the 50th percentile. So that means we got 50%, right? About 50% of people are going to be less than or equal to that, right? Or greater than or equal to it. So, and then there's 100 students. So that means this is about 50 out of 100 students, right? So once we get around 50 students, then we know that we're around where the median is, okay? Because there's 100 students, half of 100 is 50. All right, so here we got 0 plus 16, that's 16. And we want to start from the left side, right? So we're going to start from the smallest score and work our way up, okay? So we got 0, this is going to be 16, but 16 plus 42 is 58%. Okay, so that means we're already in that area of the median, okay? So that means it has to be this, between 70 and 80. So it has to be somewhere in that range. Okay, so the answer has to be C. All right. Now we're on down to our free response. So the back-to-back stem and leaf plot below gives the growth in millimeters of 23 flower bulbs planted by a 5th grade class. The plant heights were measured after 1 week of growth and after 2 weeks of growth. Determine if there are any outliers for either of the two groups. Show work. Okay. So outliers. So in order to calculate outliers, we need to use the 1.5 IQR rule. Okay, so we're going to look at the so we're going to look at the 1 week group, and then we'll look at the 2 week group after 1 week, after 2 weeks, to see if there are any outliers. Okay, so let's look at the after 1 week group. So here we have we want to find the interquartile range for the data, and so in order to do that, we need to find our quartiles. So now this is already put in order, right? So here we can list out the numbers for the after 1 week. It says 4/2 represents a plant with 42 millimeters. So this is going to represent 3. So 3/0 in this case represents 3 millimeters. And 4/0 represents 4 millimeters because it's read backwards. So 4/0 is really 04. And for example, the 2/1, this is read backwards. So it's 12, not 21, okay? But if I read the 2 weeks, then that's going to be 17, okay? So the left side is read from right to left. All right, so let's list out the values. We got 3, we got 4, 4, 6, 7. Then we got 10, 2 11s, 12, 14s, 15, 16, 16, 17, 18, 18, 19. Now you don't have to list them in order, list them like this, but I figured it's a little bit easier to list them for some people. So I decided to just list them out. Now we got 21, 22, 23, 23, and 25. Okay. All right. So there's the 1 week group. And then I'll go ahead and just list out the 2 week group just so we have it. 17, 25, 3 26s, we got a 27, 3 30s, 31, 32, 33, 33, 35, 36, 38, 39. We got some 40s numbers, 42 42s, 43, 46, 48, and 51. Okay, so we got the data so that we don't have to worry about the stem plot part anymore. So now let's go ahead and find the quartiles. So since there are, in this case, it says gives a growth of 23 flower bulbs planted by a 5th grade class. So there are 23, right? Okay, so there's 23 of them, which means that the halfway point for 23 is going to be at the 12th number. Okay, so the 12th number. So we gotta go 1, 2, 3, 4. So 1. Well, I'm not gonna cross them out, but I'm just gonna underline. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this right here has got to be our median, our middle number. So 15. So now we got 11 on each side. All right, and then now that we got 11 on the left side, we got to find the median of the left side. Since there's 11 numbers, that means that we're going to look at the 6th number. So 1, 2, 3, 4, 5, 6. This is our middle number here. So this is our first quartile. 1, 2, 3, 4, 5, 6. This is our 3rd quartile. All right. So now we got our quartile, so we can find our interquartile range. So our interquartile range is Q3 minus Q1. So 19 minus 10 is 9. And then we multiply the IQR by 1.5. So we got to do 1.5 times 9. So let me do that real quick. So 1.5 times 9 is 13.5. Okay, and then we got to calculate our boundaries. So our low outlier is less than. So the rule for this is it's going to be less than the first quartile, which is 10, minus the 1.5 IQR, which we just calculated. Okay, so minus that, which is negative 3.5. And the high outlier is greater than the 3rd quartile plus the 1.5 IQR. In this case, this is 32.5. All right, and then we're going to do and so if you look at this data, there are no numbers that are greater than 32 and less than negative 3.5. So no outliers in this group. Okay. Now we're going to check the 2 week part. So again, doing the same thing that we did earlier. So look at the 12th number. 12. So this is the 2nd quartile. Then look at the 6th number of each. 1, 2, 3, 4, 5, 6. This is the 1st quartile. 6. This is the 3rd quartile. So the IQR is 3rd quartile minus the 1st quartile, which is 15. And then we're going to do 1.5 IQR. 1.5 times 15. Let's figure out what that is. Okay, so we got 22.5. And then we could do the low outlier and the high outlier stuff. the low outlier is less than the first quartile minus 1.5 IQR. So 27 minus 22.5, that's going to give you 4.5. The high outlier is greater than the third quartile plus 1.5 IQR. All right, so 64.5. Now there are no numbers greater than 64.5 and less than 4.5. So again, there are no outliers. So no outliers in either group, okay? And we showed our work. Okay. Now we want to compare the distributions. So we're going to compare them with SOX, okay? So we got shape is for the S in SOX. So if you look at both distributions, they both appear to be roughly symmetric. That looks kind of symmetric. This looks symmetric, okay? So both distributions are roughly symmetric. The center, or outliers, right? So outliers, that's the O in SOX. So we just calculated that there were no outliers in either group. The C in SOX, so center. So now we got to compare both centers, right? So we just calculated the median, so this is where it helps. So the median here was 15. The median here is 27. Okay, so we can see that the medians, the centers, oh, I'm sorry, that's not the median. The median here is 33. So the centers vary, right, significantly from 15 to 33. Okay, so the median of the 1 week distribution is 15 millimeters. Wait, was it 15? Let me double check. Yeah, 15 millimeters, which is less than the other distribution. Which is 34.2. It was, let me double check it. 33, sorry. I was gonna say 34, 32, 33 millimeters. Okay. So you can look at the center here. You can also look at the median or the mean. So if you compared the means, this would be appropriate as well, especially because they're symmetric. And so you could reuse the center as the mean. All right, that would be appropriate as well. The good thing about if it's roughly symmetric is that you could still use the median and it would be similar to what it would be for the mean, right? So in fact, if you calculated the mean for this distribution, you would get about 14 point something millimeters, which is close to the 15. If you calculated the average for the other distribution, it should be very close to the 33. So around 32 or around 33 point something or 34. So either way is fine, but here we can report the median and it's fine. And then, we spread. So the S in SOX is for spread or variability, same thing. So the spread or the variability, which one has less spread? That's what we want to look for. Which one has a smaller range and things like that, okay? So we can see that the after 1 week has less spread. It varies less than if you do 2 weeks, right? So from 3 to 20, sorry, it's from 3 to 25, right? The smallest is 3, the highest is 25. Okay, so the distribution, or the 1 week distribution, I'm just going to say the 1 week varies less than the 2-week distribution. So the 1-week distribution is the range for the 1-week distribution is 25 minus 3. You take the biggest number minus the smallest number, so 25 minus 3. Okay. Let me actually instead, the 1 week varies less than the 2-week distribution. And let me just write down the range. The range of the 1-week distribution is 25 minus 3 is 22 millimeters. The range of the 2-week distribution is, and then you can go ahead and do that, the maximum minus minimum. So it's 51 minus 17, which is 34 millimeters. Okay, so you can use that to measure the spread. All right, and that takes care of that, that question. All right, so let's look at number 12. A tennis player measures her service speed in miles per hour for each of 6 serves. Here are her results. Calculate the standard deviation of service speed using the formula and show your work. All right, so the formula for standard deviation is the square root of the sum of x minus mu, or x minus x bar squared divided by n minus 1. Okay, so the x bar is your average, n is how many serves you have in this case. There's 6 serves. So here n is equal to 6, right? And then we need to find the average of those. So what we're going to do is we're going to do this in a nice table to show our work. So we got 82, 78, 80, 72, 85, and 80. Okay, so we're going to add these up to get our total. So that's sigma x, that means our total. Let's do that real quick. So we got this. So our total is 477. And so our x bar is 477 divided by 6 serves. So we're going to divide that. 79.5. Okay, so that's our average of 79.5. So then we take each of these x values and we subtract the average. So we got 82 minus 79.5, right? So I'm just going to show one of these. So 82 minus 79.5 equals, so then you subtract those and you get 2.5. So x minus x bar. So that's what this column is for. Then you do 78 minus 79.5. So we'll just keep doing that. You get negative 1.5. You could do this part on the calculator. 80 minus 79.5 is 0.5. 72 minus 79.5. So you got negative 7.5. You got 85 minus 79.5. So that's going to be 5.5. 80 minus 70. Okay, so then 80 minus 79.5 is 0.5, right? Let me rewrite that. And then now you have to square these. So you're going to take each of these numbers and square them, because that's what this formula has, right? And so we got to square those numbers. So we got 2.5 to the second power. So that should be 6.25, but let me double check that. Yep, and then you got 1.5 squared, that should be 2.25. Now, when you square a negative number, you always get positive, so these should always be positive numbers. 0.5 squared is 0.25. Then you got these bigger numbers, 7.5 squared, 56.25, and 30.25. So if it's 56.25, and 30.25, and 0.25. Okay, and let me just double check that just to be on the safe side. Yeah, so we got each of these numbers. So let me, okay, so now we can delete these because we don't need these anymore. All right, and then now what we're going to do is we're going to do the sigma. So we're going to add them now. So we're going to add the squares. So sum of x minus x bar squared. So now we got to add these guys. So 6.25 is 2.25 plus 0.25 plus 56.25 plus 30.25 plus 0.25. So you get 95.5. All right, so that is going to go in our numerator. All right, so we got s equals square root 95.5 divided by n minus 1, so 6 minus 1. So divide that by 5, basically, okay? So we're going to do the square root of 95.5 divided by 5. Okay, don't write it as 6 minus 1. Write it as 5. And that's going to give you 4.37 for my standard deviation. Okay, and that's going to be in miles per hour, 4.37 miles per hour. All right, and there's your answer for the standard deviation. Now let's take a look at the interpretation. So what does that mean? Okay, so what it means is that when you're calculating or when you're interpreting the standard deviation, is in this case we're talking about the speed, right? So the speed of the serve, and this gives you an average, the average distance from the mean. Okay, the x bar is the mean, so this is saying what is the average distance of each of the serves from the mean. So basically we're saying that the distance or of the speeds varies from average by about 4.37. Okay, and we're going to put that in our own words here. So the speed of these 6 serves on average varies, so typically varies means on average, from the average, which is the mean of 79.5 miles per hour, and it varies by about 4.37 miles per hour. Okay, and that's the interpretation of the standard deviation, that the speed typically varies from the mean by about 4.37 miles per hour. All right, so let's look at the next question. One of the important factors in determining population growth rates is the birth rate per 1,000 individuals in a population. Below are the birth rates per 1,000 individuals for all 54 African nations from a Population Reference Bureau report. The data is provided in ascending order along with a dot plot. All right, so we got a bunch of data, we got a dot plot, and we want to find the 5-number summary. Okay, so the 5-number summary is your minimum, your minimum quartiles, and then your maximum. Okay, so that's not too bad. All you got to do is identify what's the smallest number. Smallest number is 14. Okay, what's your largest number? Largest number is 53, right? What are your quartiles? So we got to do the Q1, Q2, Q3, and we said our maximum is 53, right? Okay, so let's go ahead and find our quartiles. There are 54 nations, right, that were used in the report. So that means if there's 54 numbers, that's an even number. That means there's going to be 2 middle numbers, right? Every time you have an even number of numbers, you're going to have 2 middle numbers. So in this case, we're going to have 2 middle numbers. So that means between the 27th and the 28th number, we're gonna be looking for those two numbers, the 27th and the 28th number. Those are the two middle numbers, right? So let's go ahead and do that. So between the 27th and 28th. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 27. Okay, so they actually divided it up for you. So it's like 27 and 27. So this is actually 27 right here. So this is 27, and then this is, okay, so that means that the median has to be between those two numbers. Okay, so halfway between 37 and 38. Okay, so your median, which is your second quartile, is 37 plus 38 divided by 2. That's 37.5. Okay, now let's do your first quartile. So now now that since these are divided in half, we're gonna do the middle of the top half, the middle of the bottom half. And since there are 27 numbers on the top and the bottom, 27 is an odd number. So that means there's going to be one middle number. So the middle number in this case, so the middle number is going to be the 20. So yeah, it's going to be the 14th number, right? Because 13 plus 13 is 26, and then you have one number in the middle. So it's got to be the 14th number. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This has got to be the halfway. So that means this has got to be the first quartile. This has got to be the third quartile. Okay? All right, so 29 and 41 are your quartiles. All right, so that's our 5-number summary. That's it. That's all they wanted. Now they wanted you to draw a box plot. Okay, so using this, we can draw the box plot. Now, before we do the box plot, we need to determine if we have any outliers. So we're going to do that right now. So we're going to say, do we have any outliers? Question mark. So let's go ahead and do that. We have to show our outliers as part of this part. Okay, so we know that the IQR is the third quartile minus the first quartile. So it's 41 minus 29, which is equal to 12. And then we got to do 1.5 times the IQR. So 1.5 times 12, which is it's going to be 18. And then we got to find the low outliers and the high outliers. The low outliers are less than the first quartile minus the 1.5 IQR. The high outliers are the third quartile plus 1.5 IQR, which is 59. Okay, so are there any numbers less than 11 but greater than 59? There are no numbers less than 11 because the lowest is 14. No numbers greater than 59 because the highest is 53. So no outliers. All right, so now we can go ahead and proceed with the box plot. Starting at 0, and we'll go by, I guess we can go by tens, because the highest is 53, so we give, and then the smallest is like around 14. Okay, and this is the birth rate. Per 1,000 population. All right, so the minimum is 14. It's got to be right around here. The first quartile is 29, so it's close to 30. The second quartile is 37.5, so this is 35, so it's got to be like around here. It's 37.5. Close to the 40, and then 40, and then the third quartile is just above 40, and then lastly the maximum is 53, so it's going to be right around here. All right, and then we can draw our box and our whiskers. All right, and there's our box plot. Some people like to do lines here. That's fine too. It doesn't matter. You can just do dots or lines, but there's your box plot. Okay, so part C, how can you tell without doing any calculations that the mean birth rate is less than the median birth rate for these 54 African nations? So so now you can see that based off of this distribution, this tail is longer, which means that it's skewed left, right? So it's skewed to the left. So the distribution, you can also see that the median is here. If the median is to the right of the center, then it also tells you it's skewed left. So there's two ways to determine that it's skewed left. So the distribution is skewed to the left. So the mean birth rate is less than the median birth rate, okay? And that's it. Without doing any calculations, you can tell. All right, so now we are looking at number 14. Yeah, number 14. So number 14 is a histogram problem. So here are the number of home runs hit by 20 Major League Baseball teams during the 2019 season. So we got 20 of them. And construct a histogram with 5 classes. Okay, so remember, to construct a histogram, you need to first calculate the class width. So the class width is the range divided by the number of classes. And the range is the maximum minus the minimum. Now here, do they put the numbers in order? They do not. So we need to make sure. We don't have to put them in order, but we just have to find the biggest and the smallest. So here we got 307 appears to be the largest, 307 home runs. And the smallest appears to be 146, right? Okay, so we got 146 and 307. So we're going to subtract those. Then divide by the number of classes. They said 5 classes. All right, so we get 307 minus 146, 161 divided by 5. So that's 32.2. All right, so we get 32.2. Then we're going to bump this up to 33. We're going to bump this up because we always bump up the class width to give us a little bit of wiggle room. Since the data is whole numbers, we can just bump it up to a whole number, 33. All right, so now we can set up our classes. Our class and our frequency. So we start with the smallest number, which is 146. And we add 33 to it, the class width. So 146 plus 33 is 179. And then 179, we keep doing that. We keep adding 33 until we get to 5 classes. So 179 plus 33. So 179 to less than should be, so 30 plus that is 209, so it should be 212. Okay, and we'll just keep doing that. Let me just double check that the math is right. Okay, 212. So then 33 plus that's 245, and then 245 to less than 278. And then 278 to less than, so this is the 5th class now, so I only need to do it one more time. So add 33 to that. So that's going to be 311, but let me double check that. So 311, okay. All right, so there's 5 classes. So now we can go ahead and count how many numbers are in each class. So 146 to 178, because we want to be less than that, right? So how many numbers from 146 to 178? We want to be less than that. 146 to 178. So 146 to 178. So this is 1, right? So I'm going to cross that out, and let me cross that in red. So it's 1, 2, and it looks like that's it, right? So it's two numbers from 146 to 178. Then we got 179 to 211. 179 to 211. That's 1. Okay. And that seems like 1. Now I forgot to count the 146, so the 146 is actually should be counted there. I forgot to do that, so that's actually 3 for that guy, right? All right, so that's good. So now we got 3 and 1. And now 212 to 244, right? So this is 1, 2. That doesn't count, right? 3, 4, 5, 6, 7, and that's 7. Okay. All right. Now we want 245 to 277. So 1, 2, 3, 4. So it looks like 5. Now 278 to 310. So we got 1, 2, 3, 4. All right, so there we go. So we got 4. All right, so now we can make the histogram. So let's go ahead and do that. So in this class, the classes represent the number of home runs, right? So I'm going to put the number of home runs. And then I'm going to put the frequency. You can put frequency for the y-axis, but you can also say the number of teams, right? So the number of teams that had those number of home runs. So I'm just going to put the number of teams, which would be your frequency, right? All right, so here the largest number of teams is 7, the smallest is 1. So we'll just go by ones. 1, 2, 3, 4, 5, 6, 7. And the number of home runs, we got 146 to 179, 179 to 212, 212 to 245. These have to be the same, like width apart. $245 to $278, and then $278 to $311. All right, so from 146 to 179, there were 3 teams that hit that many runs, home runs. And then from here to here, there's only 1 team. Then from here, there were 7 teams. Then 5 teams. Then 4 teams. All right, so here's our distribution. That's our histogram. All right, guys, I hope you found this video useful and informative. And as usual, I'll see you in the next one.